Okay, and in this video we will replicate a typical inversely S-shaped cost function in the corresponding U-shaped marginal cost function. So let's do that again in Excel. I do that again in a new sheet, and let's first write down again the function and let's derive them again. So I'll do that again with the equation editor. So the total cost function was equal, maybe I can make that bigger already. Okay, so the total cost function is given by 0.05 x cubed, so that's the output. We want to know how much each unit costs, so we go to insert equation, okay, let's do it again. So total cost equals 0.05 x cubed okay, so there should be a times in between, x cubed minus 0.75, then minus 0.75 x squared, then plus 4x, and then we have still this plus 5, which is the fixed cost. Okay, and then I'll copy this quickly here, and then we derived the marginal cost. Okay, marginal cost, MC. Okay, so from the total cost function, the 3 goes in front. So then this is 0.15, and then we have to subtract it from the exponent. 1, 2. In the next one, the 2 goes in front. 2 times 0.75, that's 1.5. And then we have to subtract 1, so that becomes the invisible 1, but in this case I'll just show it. And then here we would have the invisible 1, it goes in front, so 4 times 1. But then we have to subtract from the invisible 1 another 1, so that gets you x raised to the 0, which is 1. And of course, the fixed cost is independent of outputs. I cannot derive anything here. So those are the two equations that I'm trying to show you now. And so now we start in the first column again with x. And I do that again from 0 to 10. So we highlight the column, we go to insert, actually home, fill, series, step value 0.1, stop value 10. Okay. Then we have the total cost, TC. So now let's enter this formula, equals 0.05 times x cubed minus 0.75 times x squared plus 4 times x plus 5. Okay, so now we can copy this down. Now let's do the marginal cost. So we just enter the formula. We always start with equal 0.15 times x squared minus 1.5 times x If you want to, you can say raised to the 1, but that's completely superfluous. Plus 4. Okay, and now we copied those formulas down, and now we can see what those graphs look like. Let's first start with the total cost function. Insert recommended chart, and you see it's nicely inversely S-shaped. So actually I didn't want this one, I wanted the other one. Insert recommended chart, I take this one. And as always, we can nicify it a little bit. We can say, okay, I want at least a vertical axis title, which is total cost. Total cost. And the x-axis format that to. I want it on tick marks. I want the space between the tick marks of 10. And I want the labels to be spread out by 10 as well, and I always like the vertical grid lines too. And there are many things you can always do in Excel to make something nicer. Okay, so now this is the total cost function. You see it's inversely S-shaped. Now we do the marginal cost function, which should look like a U. And so now I need to highlight just the third column. And now insert recommended chart, and you see indeed we get a marginal cost function which looks like a U. Let me cut that and put it underneath here. Okay. Let's add the axis title on the vertical, and that's the marginal cost. We can also add the vertical grid lines. Of course, now we have to remove the spacing. So first we want all the dots on the tick mark, then space it out by 10 and also space out the labels by 10. Okay, and now we can see again that the marginal cost curve represents the slope of the total cost function. So for example here the slope is obviously much steeper, so that gets a high value here. But then here, around there, there's like a minimum, so the slope is very steep, the slope is very low, so it gets a low value. But then maybe beyond a quantity of 5, again, the slope becomes steeper and steeper and steeper, which is reflected here by higher and higher values. Okay, so I hope at this point the relationship between a total cost function and a marginal cost function, a production function and a marginal product function, and a utility function and a marginal utility function is clear. And in the next and final video, I still want to do a simple example of a utility maximization problem. And yeah, but I'll do that in the next video.